Hello and welcome to Prime Math Tutorials. Today we'll take a look at graphing the function x squared minus 2 all over x, and hopefully you gain something valuable out of it. Let's get into it. Firstly, for part A, we are required to find the intercepts. Recall that to find the x-intercept, we need to set y is equal to 0, or equivalently, f of x is equal to 0. Doing this, we get the equation 0 is equal to x squared minus 2 all over x. Multiplying both sides by the x in the denominator, we get 0 is equal to x squared minus 2, which we can use the difference of two squares to factor. Since we have x squared minus 2 in the form a squared minus b squared, it tells us that b is the square root of 2, and so our factorized form is x minus square root of 2 times x plus the square root of 2. Thus, we can read off our solutions. That is, x is equal to plus minus the square root of 2, and so our x-intercepts are x equals plus minus square root of 2. Now to find the y-intercept, we need to set x is equal to 0. However, since x is in the denominator, that would mean substituting 0 into the denominator, which we cannot do, since we cannot divide by 0. Hence, there is no y-intercept. On to part B, we need to find the horizontal and vertical asymptotes. To find the vertical asymptote, we need to look at what value of x makes our function undefined. Since we are dividing by x, this tells us that our function is undefined at x is equal to 0. Now, since we have a vertical asymptote, it is useful to see what our function looks like when on either side of the asymptote. Although this is not specifically asked for in our question, it is a step which will help us when graphing, as seen in previous videos. An easy way to do this is by plugging in values very close to x is equal to 0 into the function and evaluating this using your calculator. Doing this, we find on the left side of x is equal to 0, using a value of x is equal to negative 0.001, the y value goes towards positive infinity, inferred from the large result. And on the right side of x is equal to 0, using a value of x is equal to 0.001, the y value goes towards negative infinity. This information will be useful when graphing the function. Now to find any other asymptotes. This function is dissimilar to functions looked at in previous videos. Since the leading degree in the numerator and denominator are not equal, we cannot use the limit method to find the asymptote. It turns out that when we have a larger leading degree in the numerator compared to the leading degree in the denominator, then we can utilize division to find an oblique asymptote, also known as a slanted asymptote. In this case, the denominator is a simple expression, and so we can easily divide the numerator x squared minus 2 by x, giving us x minus 2 over x. Here we have our original function decomposed into two terms, which you'll see often with these questions. When in this form, we can identify our asymptote as a term which does not involve a fraction, so in this case our asymptote is y equals x, which I've colored in red. Now if you're unsure as to whether this works, let's take a look at what happens when y equals x, or equivalently f of x is equal to x. On the right side you can see that we have x is equal to x minus 2 over x, and so the x's cancel out. This gives us 0 is equal to negative 2 over x, which we can simplify by multiplying both sides by x, giving us 0 is equal to negative 2. Hence our function is undefined when y equals x. So, just to reiterate this idea as it is new, if our function has the same leading degree in both the numerator and denominator, we can use the limit approach. And if the leading degree in the numerator is greater than the leading degree in the denominator, then we can perform long division to decompose the function into a form similar to the one we have here, and read off the asymptote. In later questions, we will explore asymptotes which are not linear but can similarly be read off from this form. Now for part C, sketching the curve. Here we can write out the information we have accumulated from the past questions and present it in an easy to understand way. From our table of information, we can read off and plot our x-intercepts, which are at x equals negative square root of 2 and x equals positive square root of 2. On the other hand, we do not have a y-intercept, so there's nothing to plot for that. Following this, let's add in our asymptotes. We found that there was a vertical asymptote of x equals 0 and an oblique asymptote of y equals x. Additionally, although I haven't shown any working, it is easy to show that this function is odd, which tells us that this function is symmetric with respect to the origin. Using our table of information, we note that the curve goes towards negative infinity as the function approaches x equals 0 from the right side, so we can plot a point there. Then, using our table again, we can plot a point at positive infinity on the left side of the asymptote, which will further help us construct the curve. Looking at the right side of the asymptote, the function goes from negative infinity, then passes through the x-intercept x equals the positive square root of 2, and then converges to the asymptote y equals x. To have a clearer picture of why it approaches y equals x from below, let's take a look at our decomposed function f of x equals x minus 2 on x. Notice that for every positive x, we are subtracting some value away from x, and as x increases, this value being subtracted decreases. This shows why the function converges to x from below. Based on this, we can construct the described curve on the right side, and then, using the same approach, or using the geometric property of odd functions, we can construct the curve on the left side of the asymptote, to sketch the final curve shown here. Well, that's it for this video. I hope that helped, and if you have any feedback or questions, please comment. See you next time.